Hi, I'm going to talk about C language today. For people those who are new to programming language, so let us compare a programming language with a natural language. What is a natural language? So natural language is used as a medium of communication between two people. Similarly, a programming language is also used as a medium of communication, but between a person and a computer. So how? Suppose if I want to inform my computer to do something, so I have to convey only through a programming language. So that is how a programming language is more or less similar to a natural language. So suppose if I want to learn a new programming language, it is more or less similar to start with a natural language. The same steps I have to follow. Suppose if I want to learn the language Hindi, so what will I do? I will start with the alphabet. Then I will move on to the words. Then words are grouped into sentence based on grammar. Similarly, the sentence are grouped into passage. The same steps is what I am going to follow in learning a programming language as well. So if I want to learn a programming language, here again we start with alphabet. Here we call it as a character set. So these characters are grouped into something called tokens. So these tokens are grouped based on a rule called syntax into statements. These statements are grouped into finally a function, program, procedure, module, whatever the name we call it as. So if I want to start learning a programming language, I need to follow in this particular order. To start with a character set. So this is the characters supported by C programming language. So C programming language picks the characters from ASCII character set. This is an universal coding scheme that called as American Standard Code for Information Interchange. So characters are picked from this coding scheme and as part of C programming language. So if I want to write a C program, I need to pick only the characters from this particular character set. So these characters now can be grouped into something called token. Tokens are nothing but a meaningful collection of characters. So these tokens are further classified into keywords, constant, identifier, operators, special symbols, etc. To start with, what is a keyword? So keyword are group of character which is going to have a predefined meaning. So meaningful group which is again already identified with a particular meaning, we call it as a keyword. So keyword once defined cannot be changed. It remains same throughout. For example, if you take int, is going to be same throughout as part of my program. So I cannot change the meaning of this int anywhere as part of my program. So there are totally 32 keywords as part of C programming language. So then comes constant. So what is a constant? So anything which is going to remain same throughout my program, I call it as a constant. For example, I have a piece of code like this. This 20 is always going to be 20 in my program. Similarly, this 0.28 is always going to be 0.28 in my program. So this things is called as a constant. So the constant is generally classified into two groups. One is numeric constant, the other one is character constant. So these are the examples for numeric constant. So this numeric constant is again classified into integer constant, a real constant. So a real number example is 0.28, integer number example is 20. So characters are again classified into a single character constant, a multi-character constant. A single character constant is defined as a character constant, a multiple character constant is defined as a string constant. So these are a general classification of constant. So now let us see how these constants are going to be stored into your memory, because these are going to be the basic units of any program. How these informations are going to be stored into the memory. So every data, every constant, every information will definitely occupy a piece of memory in your computer. So memory is being structured as a collection of locations. So here this is a structure of memory. So this collection of location we call it as a memory, where each and every locations are addressed uniquely. Each and every location will be distinguished from one another with the help of unique address. So the data will be stored in these locations. The data will be stored in this location. And how the data are going to be stored in this location in terms of bits. Data will be stored in terms of bits. So every location is divided into 8 bits. In each and every bit we can store either 1 or 0. You can just store the information in the form of 1 or 0. So 1 stands for on, 0 stands for off. So this is how the memory is being organized, and all our information gets stored in this memory. Now let us see how this integer data is going to be stored into the memory. So here if I take integer 0, 1, 2, 3, 4, so on. So this data will be converted into binary equivalent. So every decimal number will be converted into a binary equivalent. Binary equivalent will be in terms of zeros and 1. My computer can understand only zeros and 1. So it will be converted into a binary equivalent, and this binary equivalent is what going to be stored as part of my memory. For example, if I have 0, the 0 will be stored as all zeros in this particular place. Similarly, if I have data 1, so 1 will be stored as 0, 0, 0, 0, 0, 0, 0, 1. So this is how my data 1 is going to be stored. For example, if I take 5, so binary equivalent for 5 is 101. So this 5 will be stored as 0, 0, 0, 0, 0, 1, 0, 1. So data 5 is going to be stored as 5 zeros, 1, 0, 1. So in physical memory, my data will be stored only in this particular format. Now, when you have a larger number, what will you do? In the previous example, when I have all the 7 ones, I will be able to represent only 255. When you have larger number, what will you do? When the numbers are going to be large, we try to occupy more number of positions, more number of memory locations for a single number. How? So for that, we use two formatting schemes. One is Little Indian format, the other one is Big Indian format. In case of a Little Indian format, the numbers are stored in consecutive bytes, where the least significant byte is stored in the first location, and the next least significant byte will be in the next location, and the third one will be followed further. Where in case of Big Indian architecture, the data will be stored in the reverse. The most significant byte will be stored in the first location, the next most significant byte will be in the next location, and the third most significant byte will be in the further location, and so on. For example, I have a number 256. The 256 is going to be 1 followed by 8 zeros, but in a single location I will be able to store only 8 bits, 8 zeros, but here we have totally 9 bits. So how 256 is going to be stored now? The 256 is going to be occupying two locations. So if I use Little Indian architecture, the least significant 8 bits will be occupying the first location. The most significant 8 bits will be occupying the corresponding location. 0, 1 will be in the next location. Similarly, the integer number 1000 will be converted in binary as 111, 1101, 000. So the least significant 8 bits are stored in the first location. The most significant remaining bits are stored in the next location. So now the single data 256 is going to occupy two locations. It is addressed by 1001. 1000 is occupying two locations. It is addressed by 1003. Similarly, 999 is going to occupy three locations, and it is addressed by 1005. This is in case of Little Indian architecture. Similarly, in case of Big Indian architecture, it will be reverse. The most significant byte, that is 1, will be occupying the first location. 8 zeros will be occupying the next location. So this depends on the architecture what your computer follows. Based on that, the storage will take place. But anyhow, the integer constant, the integer data are finally going to be stored into the memory only using this principle. So now, what will you do if in case you have a negative number? A positive number will not be an issue. What will you do in case of a negative number? So when we have a negative number, the data are going to be stored using 2's complement representation. So when I have, for example, -5, minus 5 will be converted into 2's complement representation. It will be converted into a binary. Its binary equivalent will be converted into a 2's complement representation, and that information will be stored into the memory. So all cases, the MSB, most significant bit, will act as a sign bit. Sign bit means this indicates whether your number is going to be a positive number or a negative number. So whenever I have 0, that indicates it is going to be a positive number. Whenever MSB is going to be 1, it indicates a negative number. So the 2's complement automatically fill 1 in the MSB bit. So this is with respect to a negative number. So the same with respect to higher order also. Everywhere we'll be converting that into 2's complement representation. We will just store that over here. For example, number 5, this is the binary equivalent, this is the 2's complement equivalent. So now what will happen with respect to a real number, I mean a floating point number. So a floating point number will be using IEEE floating point representation format. So what is this IEEE floating point representation format? It is actually a universal standard. So this is a simple form of IEEE floating point standard, IEEE 754 standard. For an example of 8-bit, this 8-bit is divided into 3 groups. One, the MSB, we call it as a sign bit of my number. Next group, 4 digits, which is going to use for representing the exponent part. The last three bits is used for representing a mantissa part. For example, when I have a number 36.25, so I am converting that into binary. 36 is converted into 100, 100. Similarly, 0.25 is getting converted into 0.01 binary. So I'm just converting my number into binary. So this is now converted into a exponent and mantissa format. So I'm just multiplying this into 2 to the power 5. So I'm getting this data as 1.001001 into 2 to the power 5. So here the sign bit is going to be 0. The exponent I'll pick from this, and mantissa I'll just pick from here, this one. So mantissa is going to be 001 and the exponent is going to be 7 plus 5, that is 1101. So the data, when it is going to be real floating point number, so that will be stored in form of an exponent and mantissa part, so where we will be using an IEEE floating point format. So this is a larger IEEE 754 standard. When we have 32 bits, one is sign bit, remaining 8 bits for exponent, 23 bits for mantissa. So now how characters are stored. So a character, as already we have mentioned, it is using an ASCII code. So every single character from this ASCII code, we call it as a character. So this ASCII code is simply going to be a number. So for example, if you refer this table, this is the ASCII number for each and every characters whatever we have listed. So every character will be stored into the memory as its ASCII value. So suppose if I want to store capital A, its ASCII value is 65. This numeric 65 will get stored into the memory as how an integer gets stored. The same concept is being stored, used to store a character also. So suppose if I want to store A, capital A, it is 65 ASCII value, its binary equivalent, and this is going to be get converted into bits and stored into your memory. Similarly, for each and every characters. For example, even a blank space, a space, everything is going to be a character that is having its equivalent ASCII value. The ASCII numeric is what going to get stored over here. So how will you represent a string constant? String constant is going to be a collection of characters. The string constant gets stored in continuous memory. So for example, a hello world string is going to be stored in 12 different locations, starting from 1 till 12. The first letter will be storing in the first location, second, third, so on, so on. So each and every character has its ASCII representation. So that will be represented, stored in form of binary. So this is how the information gets stored into the memory, and this information is what going to be processed by your program as well. So this information is not going to be of the same format. The information is going to be of different format. For example, if I take a student, student name will be as a string. If I take student roll number will be an integer. If I take student age, age will be an integer. If I take student sex, male or female, it will be a single character. If I say student percentage of marks, it will be a floating point number. So for that reason, we are just going to classify the data into different types, like character data type, integer data type, floating point data type. So otherwise information will get clumped into the memory. So to avoid that, we just go for classifying the data into different types, and these are the different types of data supported by C programming language. So these are the data and the size of each and every data. So character data 1 byte, the size is going to be between -127 to +127 range. Short is going to be 2 bytes. This is the range. Integer is going to be 4 bytes, and the range is given here. 4 bytes, I mean 32 bits information you can store. Similarly, long, float, double. So these are the data type supported by C programming language. So this is the small introduction about C language and the data type. Thank you.